Galileo Galilei not only observed the sky, he reinvented the very way of looking at the universe. In this documentary, we will cross centuries to understand how a man alone shook the intellectual, philosophical, and religious structures that seemed unshakable. This is the full journey of a genius who dared to ask what no one else dared to ask. Galileo was born in Pisa in 1564, the same year Michelangelo died. Italy was experiencing the height of the Renaissance, but it also carried religious and political tensions that would shape his life. Your father, Vincenzo Galilei, was a musician and scholar. He taught young Galileo that nothing should be accepted without question. This seed of skepticism would later blossom in the scientific revolution. Galileo was sent to the University of Pisa to study medicine, but he was deeply bored by the classes. What truly fascinated him was mathematics, motion, music, and the secrets of nature. He would spend hours analyzing instruments, mechanisms, and gears, searching for patterns that explained the physical world. Reza the legend that, upon observing a chandelier swinging inside a church, Galileo noticed that the pendulum's period seemed constant regardless of the amplitude. Although this story is somewhat romanticized, it reflects his observant and critical spirit. This perception would be essential for the development of more precise time measurements centuries later. When he became a professor at Pisa, Galileo openly challenged the blind followers of Aristotle. His classes were provocative, often questioning beliefs that had been accepted for 1,000 years. This behavior attracted both admiration and enemies, but Galileo was never afraid to challenge traditions. The most famous story from Galileo's youth involves the Leaning Tower of Pisa. According to later accounts, he dropped 2 different weights to demonstrate that they both fell with the same acceleration. Whether legend or fact, the principle proven by him is real. The movement of bodies does not simply depend on their weight, but on universal mathematical laws. Unsatisfied with Pisa, Galileo moved to Padua, a vibrant center of science and philosophy. There he found intellectual freedom to develop bold ideas. In Padua, he taught mathematics, mechanics, and astronomy, training generations of students who would later spread his experimental method across Europe. Galileo believed that nature spoke the language of mathematics. Philosophical arguments were not enough. It was necessary to measure, compare, repeat, and validate results. Your experimental, rigorous, and systematic method laid the foundations for what we now call modern science. Each test, each observation, brought human thought closer to objective reality. In the 16th century, Copernicus's heliocentric model was beginning to circulate discreetly. Many intellectuals found it mathematically elegant, but few believed in it physically. Galileo, however, saw a clue there. Something about that proposal intrigued him. What if it were true that the Earth was not the center of everything? In 1609, news of a tube capable of bringing distant objects closer reached Galileo. Quickly, he built his own prototypes, elevating his telescope to levels far superior to the original models. The world would never be the same when he pointed it to the sky. Upon examining the moon, Galileo found mountains, craters, and shadows. This contradicted Aristotle's dogma that celestial bodies were perfect and unchanging spheres. Lua was not an unreachable divine kingdom. It was a physical world with its own geology. For the first time, humanity saw another celestial body realistically. In January 1610, Galileo observed 4 small stars near Jupiter. Days later, he realized they were moving, but not around the Earth. They orbited Jupiter. These moons, Io, Europa, Ganymede, and Callisto, proved that not everything revolved around our planet. It was an undeniable evidence against geocentrism. When observing Venus, Galileo identified phases similar to those of the Moon. This could only happen if Venus orbited the Sun, never the Earth. It was the empirical confirmation that Copernicus's heliocentric model needed to stop being just an elegant calculation. Galileo pointed his telescope at the Milky Way and discovered countless stars. What appeared to be a mist was, in fact, a vast star cluster. This further expanded the notion that the cosmos was much larger than previously imagined. In 1610, Galileo published The Star Messenger, reporting his discoveries. The book was an immediate success, making him the scientific celebrity of Europe. He dedicated the work to the powerful Medici, seeking political protection, a strategic gesture during a delicate period. The Catholic Church, although initially tolerant, began to worry about the growing popularity of ideas that contradicted Bible passages interpreted literally. Galileo insisted that the Bible taught how to get to heaven, not how heaven worked. His position, although logical, irritated conservative sectors. In 1616, heliocentrism was classified as heretical. Galileo received a warning. He could not teach or defend the Copernican model. From then on, each of your words would be observed carefully. In 1632, Galileo published his boldest work, the dialogue concerning the two chief world systems. The book compared the geocentric and heliocentric models, clearly favoring the latter. The work irritated authorities who felt ridiculed. For many, Galileo had crossed a line. Galileo was summoned to Rome. Faced with the Inquisition, he endured physical and psychological pressure and a real threat of condemnation. In 1633, he was forced to publicly renounce his ideas. Nevertheless, according to reports, he murmured, "Eppur si muove," and yet it moves. This phrase still echoes today as a symbol of intellectual resistance. Galileo spent his final years under house arrest. Already blind, he dictated his works to students and assistants. Even under these conditions, he wrote essential treatises on mechanics and motion, directly influencing Isaac Newton's work. Galileo established the foundations of classical physics, observational astronomy, and the scientific method. His impact defines modern science. He showed that nature could be understood through universal mathematical laws. Without him, much of contemporary technology would not exist. More than a scientist, Galileo symbolizes the courage to question authorities. He placed empirical truth above traditions. Our history reminds us that knowledge advances when we dare to look beyond what is allowed. Galileo Galilei illuminated the path that science follows to this day. He showed that, even in the face of oppression, the pursuit of truth cannot be silenced. If this documentary sparked your curiosity about the universe, stay with us on the next cosmic journeys. Follow the channel.